Hello, good morning. This is DRRosmaini again. And this morning, I'm planning to lecture on Chapter 5 of Management Information System course. And the title for this chapter is The Foundation of Basic Business Intelligence, basically it's database. Okay, let's take a look on the learning objective of this topic. Basically, in this topic, at the end of my lecture, I'm supposed to enable you to describe how the problem of managing data resources in traditional file environment in comparison to digital database management system. By the end of the course, you should be able to describe the capabilities and values of database management system and trying to apply the principle of database management into a simple design spreadsheet. You should be able to also evaluate tools and technology for accessing information from databases using platforms in big data management, in online analytical processing, in order to improve business performance and for managers making better decisions. You should be able also to assess or to learn about the role of information policy that governs the database access and also information sharing within the organizational setting. Okay, let's take a look on this organizing data in the traditional file environment. So basically, if you take a look on any file organization concept, all databases basically is consisting of a group of related files or a related document. Within that database, just in comparison, just like your normal folder, inside there is files. Inside the files, there are records. Inside the records, there are fields. And within the field, there are two main components, which is entity and also attributes. So basically, database is a collection of file, records, entity, and attributes. So if you go to purchase books at Amazon, you can see many options of book to purchase from, for example. So those are database of books. And if you go to Shopee to purchase a product online, you can see many products being offered. Those are basically databases of product within the database of Shopee server website. So basically, the database is a compilation of many data, which is sorted based on its file name, based on record type, field name, and also its entity and attribute. I would say database exists in many systems and many devices. For example, I believe you have also a database, simple database on your palm. What could be the simplest database that you may use every day? It could be in the form of smartphone, because if you tap for your contacts in the smartphone, contacts names and phone number, you can see a list of names and telephone numbers. Those are basically a database. So I would say database is predominantly the major component of many websites that we use every day that benefit people to access data faster and more efficient. So database is the uh, intelligence inside many of the system existing every day that we use. Okay, for example, we search at the Shopee website. So you try to search treadmill. Treadmill is a machine for you to do physical exercise at home or at gym. So you search a treadmill and then press enter at Shopee. You could see a list of many treadmills available at the server website database. One would be from this Zero brand. The other one is from this Snowfit brand. The other treadmill brand from Happy Life, Global, and Johnson Fitness. So these are all databases of treadmill which existed at Shopee. So Shopee posted all the treadmill types in the website due to the existence of the list of database entry and product under the Shopee server database. So it is as simple as that. So it is a list of product within the same category shown to customer if they are asking for information. Basically, in terms of data hierarchy, okay, so for data to exist, it must have layer and it must have its organizational structure. For example, this is the database of a student at UTHM database server for uh, student record. Okay, so at the database, there is the first layer. So student database consisting of what are the courses that the student took and what is the financial status and what is their personal information file. For example, name, IC number, metric number, those are incorporated in this layer. Under this database, there is a file. Okay, and inside the file, normally it is keeping the information on student ID, like matrix number, what are the courses that you are taking, for example, BPA 20703, uh, what are the semester or the date, and what grade you have scored inside for the course inside the semester. Under the file, there is record. For this record, it has the following data name. For example, student ID header, course header, date, and grade. So for this student, for example, metric number 39044, it has taken Information System Course 101, and the date is fall semester 6, and it has attained grade of B+. Under the record, it has field. And this field is basically this course field, which is IS11 information system course that the student took. And inside the field, there is byte. Okay? There is a byte information in which normally this is kept in the information language, and information normally reads in the form of 1 and zeros. Okay, like this byte 01001001. This is letter I for ASCII. For the human language, we treated this number as decimal system 73. So under the byte, there are bits. There are 8 bits inside one byte, as I have explained in previous chapter. So this bit contain all zeros and ones. So basically, information work with 0 and 1s in creating a record, file, and the whole database for human to make use of this data for managers to make a more effective and efficient decision. Okay. Well, in this case, if we keep an information inside the field, for example, character A in the ASCII file tabulated table is represented by 01000001. It is represented. It is representing A in human language, but in decimal system it is represented by 065. So basically, computer are keeping a single character with these 8 bits of information of zeros and ones. So these are how the computer keeping the data for the database. Okay, if we take a look on the digital file database and a traditional file database, so basically, definitely it is easier to manage information by using digital file database. Okay, if you take a look on the traditional file environment, like this separate physical file like this, so basically there are many information which is redundant. Perhaps your name, it could appear here, and your name, it could appear at this, also file, also appearing. So this is called data redundancy, in which many of the same information is kept in several different files. Okay, some of the data might be inconsistent because it is manually keyed in or manually written into this file. So the problem with traditional file environment or database, it is kept in a separate file, and some of the data are repeating, and it is not related to each other. So you have to access file by file in order to find, for example, the names and prices. So in a traditional data file, which is the data are not interrelated to each other. They are separated because it is in the physical form. They are not linked to each other. So in such a traditional file, of course, data is not flexible. It is very much manual based access. And this is what they call standalone traditional file. So this file is not related or linked to this file. Okay. So there is a poor security system in traditional file environment. So you cannot secure because it is a physical file, as it is open for breach or open for data being stolen. And data sharing and availability is also lacking in terms of easiness to share data and smoothness to share data availability. Okay, in traditional file processing, you could see that if there are 4 departments in the company and they are all using traditional file, basically accounting and finance, they have their own file, human resource have their own files and drawer, sales and marketing, they have their own files and drawer, and manufacturing and production, they have their own file and drawer or physical file. However, if we transfer this into a traditional file by using a software, accounting software like a UBS, user business system, we could keep this approach in a more integrated manner. So in which application program 1, UBS, is keeping data, and application program number 2 also is keeping data for human resource. Application program number 3 for sales also their own program, and manufacturing, production scheduling, they have their own application program. So basically, all of these software are keeping their own information system and their own database. So all of these information are very much separated from each other in the traditional file data processing, in which each department keep their own information. Okay, so it is not integrated and it is not dynamically linked. However, in a digital database, in the modern computer environment, so digital database serve many applications by centralizing data and control data repeating or data redundant. So perhaps in just one file, it keeps the name, the rest it keeps the product number, the rest is keeping the production schedule, and the rest is for perhaps sales and marketing. So all these data are actually linked to each other, so that there is less need for data redundancy. So basically, in the modern database management system, there are interfaces between application or between software in comparison to traditional file data. And in DBMS, it separates the logical and physical view of data. So in such a way, you could have a better control of the data and information. So we reduce the inconsistency of data because data are very much more standardized. Okay, this is the graphical outlook of information of database for human resource department, for example. So in HRD database, this is the representation of database with a cylindrical shape. Inside this database, it keeps the employee ID, for example, matrix number, the name, the IC number, the position in the company, when you got hired, what is your total pay, what is your basic pay, what is your overall pay, life insurance, and so on. So inside this database, it is linked into a database management system, DBMS, And from such that structure, it can be split up to the record for name, IC number, and healthcare. And these are the category for benefits. And from this database system, you can separate it with the other uh, uh, category of data in the form of name, IC number, gross pay, and net pay. So inside this digital database, this name and social security number is the same exact information. It doesn't have to repeat by itself. In such a way, this benefit is basically referring to the same name and the same IC number to keep the record for their salary or their payroll. Okay, so as such, a human resource database can be viewed from many perspectives, like from the benefit view or from the, I would say, payroll scheme view. So from the same database source. This is what has been known as relational database. So in this structure, this is called related database, which is this name and SSN is related to this same name and SSN. As such, this view and this view is related, and that is why they call it is a relational database. Basically, in relational database, it is linking data in a two-dimensional table, the X table, X view, and also the Y view, or two-dimensional in the form of X-axis and Y-axis. So each table contains data, entity, and attributes. So to form a table, you need a grid of course, column, okay, and you need another row. So inside this table, basically a row is the one that is horizontally laid. It consists of records for different entities. For the field, inside the column, it represents the attitude, the attribute of the entity. Key field is uniquely to identify each record. There is a primary key and there is a foreign key to link to other table. Okay, this is the structure, how it is laid out inside a relational database. So you have a row, okay, and you have a column, and this is one table. This table is named supplier. Inside this supplier table, it has attributes, okay, and field. So this is the attribute supplier name, and it contains fields 8 to 59. And this is the supplier name attributes, and the field contains information of the company name, CBM Incorporated, and so on. So all these are basically the structure of how supplier table is made. It consists of row, okay, it consists of records, and it consists of tuples. Okay, in this table, the key field is supplier number. This is the primary key, in which if information want to access the other part of the records, then it must go through this supplier primary key, supplier number primary key. The other table is named part. Okay, it has the part number, information, it has part name information, it has unit price information, and supplier number. Okay, in this part table, so it has a primary key by the name of column part number. So this is the basically the primary key for table part. And the other on the right column, it has a supplier number, which is called foreign key. Okay, so if this if information want to be accessed from supplier to this part table, so basically information can be accessed from this table to this part table through the primary key and supplier number, accessing supplier number column in part table, and then you can access unit price, part name, and also the part number. So this is how it works for relational database. Normally it has the primary key and this primary key column exists on the column of other part table in which the other information can be accessed. Basically, in the operation of relational database, in order to see many views of many information on other table, you have to select, and then you have to join those what you select, and then you can project what is actually you want to see. So the procedure in the database, you have to decide selection, and then join the selection that you want to see, and then show what are the information that is the only information that you want to see in the view or in the screen. Okay, for example, this is the tree table. The tree table is consisting of the part table, supplier table, right? So this is basically to show the this table of part number, part name, supplier number, and supplier name. For example, you are the cashier or the person in charge, which is keeping the information for a supplying company. So in the computer screen, there are limited information you can show or see at the computer screen. Perhaps you want to know only what is the part number that customer order, what is the name of the part number, what is the supplier number for you to manage the order, and who is supplying the products. So out of these two table, part and supplier, you want to see only two part number, which is door latch and door molding, part number 137 and 150 respectively. So for this case, you need to select and then join and project. You need to select and then join with other table information that you can combine and later project only this piece of information. Okay, so in this case, for part number 137, basically door latch. For part number 150, basically door molding. And show me only the part name, which is you can get from here, and show me only supplier number, which is 8259, and also 8263, which is this and this, and tell from the system, tell me or the manager what is the supplier name, which is CBM Incorporated and Jackson Component. So database enable us to see only the information that we need in order instead of seeing all the information which is available inside the database, which are too much for us to make sense to make decision. So as such, just select, combine or join with other information which are needed, and then show the needed information on the screen. So that is how the relational database works. Okay, in the database approach to data management, basically there are relational database, some other also non-relational database. Some database exist in the cloud, for example, like Amazon relational database or Microsoft SQL Azure, and so on. There are many types of databases. So in the database management system, there are many capabilities in which mostly the data definition has its own structure so that it can house the content used to create tables or related tables and define characteristic of the field. It has the data dictionary in which keeping the element and characteristic of information together. And as such, you must have the database programming language. They call it manipulation language. For example, SQL language or Microsoft Access. That is also another familiar software. So those are the capabilities for data management system in order to operate. Okay, let's take a look the data structure for Microsoft Access software. For example, if you are setting up the database that we have discussed earlier for the supplier number, supplier name, street, city, state, and postcode or zip, So all these field name must be dictated or must be decided for the computer to keep. For example, supplier number. Mostly it is number like 3278. Okay, for supplier name, it should be data type text, which is A, B, C, D. Okay, and for the supplier street, it should be Roman A, B, C, D, same as city, state, and zip. Zip could be number and alphabet, and as such, it is called text data type. Okay, and we have to set up also the property fields. For example, field size, how it should be filled with information. It should be for field size in the long integer and decimal places. For example, it's set at auto. So in this Microsoft SS database structure, all this information must be decided and must be key into the field in order for the software to work properly. Okay, for example, you have this a query or a request of information. Okay, for example, this is the table for select part, which is this. Okay, from the select part, you can see part part number, you can see part name, you can see unit price and supplier number. From the supplier table, you can see supplier name. Okay, and from the supplier where part, which is supplier number, okay, equal to supplier number and part number 10137 or 105. Okay, so say you are as an employee, you want to see the part number, these two part number, which is 137 and 150. What you need to do is you have to take the information from here and here, select, and then okay, join it, okay, with the other information from supplier number and supplier name, in which you can get it from here and here, right? So you join it with this information supply table, and you project it here. So select and then join and project this table, because you want to work only on these two product to be fetched for delivery. Okay, that is how the SQL query works. Okay, so in this Microsoft SS query, basically this part table consisting of part number, part name, unit price, and supplier number. In order to access from the supplier table on the supplier number and name, you have to follow this supplier number. It goes to this table supplier number, and you can access supplier name. So, and the setting of the field table is also set here. For example, part, okay, which is 137 or 150, part, which is a part name. From the supplier table, you are interested on supplier number, and from the supplier table, you are interested only on the supplier name information. So these are the setting at Microsoft Access based on your query. So how to manage this database? What's the approach? Basically, you have to have the design approach. You have to have the process to identify, and you need some sort of rules or normalization in order to access your data. Okay, data can be existing in scattered forms. For example, it is not in the particular order. For example, you have order number, order date, part number, unit price, supplier city, supplier zip. It could be jumbled up. But in order for SQL to work, you need to make it in order and separate it based on category type. For example, this is part which house the information for part number, part name, unit price, and supplier number. And this is the table for line item. It consists information of order number, part number, and part quantity. And this is another set of information of supplier table. It consists of the information on supplier number, supplier name, and up to supplier zip. The other table consists of the order number and order date, because it is basically keeping the information about order. So in this normalized table created form, it has 4 table: part table, line item table, supplier, and order. So this is what they call the the setting has been normalized, which is all parts information are table inside the part table. All line item are consolidated into line item table, respectively with supplier and respectively with order. So this part table has the part number as the key. This line item has the order number and part number as the key. The supplier table has a supplier number as its access key. The order table has the key column as the access for information in the order table. So if you have a supplier number here, okay, you can access the information from the part table from the supplier number. You can access unit price, part name, and part number. From this part number, you can access line item table, which is this is the key part number to access information on order number and also to access information on part quantity. From the order number, you can access the order table, because this is the key, primary key for order table, which contain information about order date. So this is what we call the table has been normalized or categorized according to their particular set of information in comparison to the previous data, which is not under specific arrangement of type of information. Okay, so let's take a short break at this middle of the lecture. I will continue part 2 of the lecture with this entity relationship diagram uh, for the continuation of the next part 2 lecture. So thank you. I'll see you soon.